When you start using algebra and learning how to solve equations, it's quite a natural thing for students to wonder, what's the point? But the point is that we use formulas a lot in everyday life to actually help us solve problems. And we use formulas so that when we know one thing about an object or something like that, we can find out something else. So for example, here I've got some formulas on the board that are really commonly known and used by people. The first one is to find the area of a circle. But you can't find the area of a circle unless you know the radius of the circle. If you know that, you can substitute it into this formula and you'll figure out the area. This one is for the volume of a rectangular prism. But you can only find the volume of a rectangular prism if you already know the length and the base and the height of that prism. Then all you'll need to do is apply this formula. This one converts temperature in Celsius, degrees Celsius, into degrees in Fahrenheit. And that's helpful depending on where you live in different parts of the world so that you can convert back and forth. Now, there are apps and things that can do some of these conversions for us, but really today we're just trying to understand how we can substitute values into formulas so that we can come up with some of the answers ourselves. Now, one of the key things that you need to know is the fact that multiplication signs are left out when we're making algebraic expressions. So for example, here we have pi, which is just a number, 3 and a bit, and our calculator can help us with that. Pi r squared looks like it's all smooshed together. There's actually a little invisible times sign in there, so what we really want is pi times the radius squared. Here, the L and the B and the H are all smooshed together. What we really want to do here is length times base times height. So the times signs are often left out, and if you're ever unsure why two letters are smooshed together, there will be an invisible little multiplication sign in there that's just not written. In this one, we've got 9c. That means 9 times c. The rest of it's fairly self-explanatory. Division is generally shown with a fraction line, and you can put it into your calculator exactly like that. And pluses and minuses are there exactly as you'd expect them. So let's have a go at substituting some values into these formulas. What would be the area of a circle when the radius is 3? Well, all we've got to do here is rewrite what we're given. Area equals pi. I'm going to put in the little invisible times sign because I'll need to put that into my calculator. And then instead of writing r squared, I'm going to write 3 squared. Now you can reach for your calculator. You might know that 3 squared is 9 in your head, and if you do, that's great. But what if this is a nasty number like 2.85? And squaring 2.85 in your head takes a bit of time. So we can put it in exactly like this. To get pi, we do shift, and then the button in the middle of your calculator at the bottom, that gives you pi, times, and then hit the 3, and now you can hit the x squared button, equals, and we get 28.274333. So it goes on and on. We need to round off our answer to something that's sensible. It's 28 and a bit. I'm going to round off to 1 decimal place, 28.3. Now I should have really had units on this. If r is 3 centimetres, then the area will be in centimetres squared. Okay. Now for the next one, I've got volume. I need to just substitute in. What is L? 3 centimetres. What is B? 4 centimetres. And what is H? 2 centimetres. And you'll notice in my working, I've put the times signs in, even though they weren't visible there in the formula. Now 3 4s are 12. 12 2s are 24, so I can do this one in my head, but feel free to use the calculator if you want to. And I've got centimetres times centimetres times centimetres. And when you multiply something by itself, you're raising it to a power. This is actually centimetres cubed. And you might already be familiar with the fact that when we're working with volume, we have cubic units. All right, for the last one, if we have 20 degrees Celsius, what would that be in Fahrenheit? Well, all we need to do is substitute in 20 where the C was. So we have 90 times 20, and I'm going to put that invisible times sign in, over 5 plus 32. And you can put it into your calculator exactly like that. So make a big fraction, put your 9 times 20 on the top, your 5 on the bottom, use your cursor to get out of the fraction, add 32, and we get 68. So 20 degrees Celsius is the same as 68 degrees Fahrenheit.